Hi, good evening, everyone. This is Shefali Singla, and in this session, we'll continue our discussion with the practice questions on Unit 2. So, in today's session, we will be discussing a few questions which have been asked in the previous year UGC NET papers. So, her question ke liye I'll be giving you 2 minutes, and if you have any doubt, please feel free to write in the chat section. Okay. Very good evening, Nitika. Good evening, Shubham. All right, so let's move on to the first question. You are given with the equation, and here you are supposed to find out the value of the base. That is, base is b. इस type का question हम पहले भी कर चुके हैं. So again, the similar question was asked. So I discussed two methods. एक तो है कि आप इसको decimal में convert कर लीजिए and then solve the equation, because here you will be getting an equation. Or other method is whatever options are given to you, substitute the options in the equation and check कीजिए कि जो left hand side और right hand side से value आ रही है, are you getting the same value? Although the first approach is better to convert this into the decimal, find the equation and find the roots for that equation, but अगर मान लीजिए आपको quadratic equation solve करने में problem आ रही है, आप फंस गए हैं, तो उस केस में आप option substitute करके भी answer find कर सकते हैं. So first of all, let's go with the method 1. Approach 1 will convert this equation to the decimal. Very good evening, Shikha. इसको डेसिमल में कन्वर्ट कर लीजिए. हमें मालूम है कि जब डेसिमल में कन्वर्ट करते हैं तो वी नीड टू कंसिडर द पोजीशन ऑफ द डेसिमल. दिस इज 0 1 2. दिस इज अगेन 2 1 0 2 1 0. So this comes out to be 1 into b square plus 4 into b raised to power 1 plus 6 into b raised to power 0 plus, now I'm expanding this term. This is 3 into b minus 2 whole square plus 1 into b minus 2 plus 3 into b minus 2 raised to power 0. Anyhow, that is 1. आप इस term को skip कर सकते हैं. 2 into 8 square plus 4 into 8 raised to power 1 plus 6 into 8 raised to power 0. Can you tell me that what quadratic equation are you getting? So just expand this. This comes out to be b square plus 4b plus 6 plus 3b square plus 4 into 3 is 12. So it will be plus 12 minus 4b into 12 minus 4b into 3 is 12b minus 12b plus b minus 2 plus 3. Okay, so we have expanded this term, and then it is 8 square is 64 and into 2 is 128 plus 32 plus 6. Simplify this equation, find out the factors, roots of this equation. So this equation is simplified to 3b square plus b square is 4b square minus 12b plus 5b is minus 7b plus 19 is equal to 166. So this equation comes out to be 4b square minus 7b minus 147. So this is 4b square minus 28b plus 21b minus 147. Just simplify this one and find out the value of b. सी आपके पास ये क्वाड्रेटिक इक्वेशन आ गई. इसके बाद आप इस क्वाड्रेटिक इक्वेशन को कैसे सॉल्व कर रहे हो, इट्स अप टू यू. वेरी गुड इवनिंग हेमंत. ये आपके पास क्वाड्रेटिक इक्वेशन आ गई. इसके आगे आपको सिर्फ क्वाड्रेटिक इक्वेशन को सॉल्व करना है. आप फॉर्मूला यूज कीजिए, फैक्टर्स को डिवाइड कीजिए, व्हाटएवर यू वांट टू डू यू कैन. So here we are getting 4b, it is b minus 7 plus 21b 21b minus 7 is equal to 0. So this comes out to be 4b plus 21 b minus 7 equal to 0. इनमें से कोई तो एक factor 0 होगा. So if this is 0, from here we are getting b is equal to 7. So 7 is the correct answer. Option 2. दूसरा मेथड आपको बताया था, जो भी ऑप्शंस दी हुई हैं, substitute this in the equation and find out the values. So one by one you can try substituting each and every option. Let me give you the hint. जिन लोगों ने फर्स्ट प्रैक्टिस सेशन अटेंड नहीं किया था, दिस इज मेथड 2. सी ऑन राइट हैंड साइड दिस बेस इज नॉट गोइंग टू चेंज. इसको आप एक बार सॉल्व करके रख लीजिए. उसके बाद जस्ट यू नीड टू एक्सपैंड दीज टर्म्स and you have to check whether you are getting the term equal to whatever you are getting on the right hand side. So on right hand side, 246 with the base 8, this will be expanded to 2 into 8 square plus 8 4 into 8 plus 6 into 8 raised to power 0. And we have already calculated this. This comes out to be 166. Okay. Now take each option with the base 8. Whatever is the base value, just substitute it. I'm trying with the first option. So 146 base 8 calculate करना है. जो भी value आएगी, just add it to 313 with the base b minus 2. So 8 minus 2 is 6. Calculate this. It will be 8 square plus 4 into 8 plus 6 into 8 raised to power 0. इस क्वेश्चन में इस मेथड का बेनिफिट क्या है? ये आपके पास कोई इक्वेशन नहीं बनेगी. इवन इफ यू आर अनेबल टू सॉल्व द इक्वेशन, इवन देन यू विल बी एबल टू सॉल्व इट. बट द प्रॉब्लम विद दिस मेथड इज दिस इज लेंथी. मान लीजिए ऑप्शन 4 करेक्ट आंसर है, तो एक एक करके आप चारों के लिए वैल्यू सब्सटीट्यूट करोगे. बट इफ योर कैलकुलेशन इज गुड, देन यू कैन प्रोसीड विद दिस मेथड ऑल्सो. सो इट इज 3 into 6 square plus 1 into 6 plus 3 into 6 raised to power 0. So it comes out to be 64 plus 32 plus 6. So 70, and this comes out to be 102. This is 108 plus 6 plus 3. 108 plus 9 is 170. So take the sum. This comes out to be 912. Is this equal to 166? No. So this means that option 1 cannot be the answer. Similarly, we'll try for the remaining options. Now we'll be calculating 146 with the base b. B is 7 and 1313. 7 minus 2 is 5. Calculate it. So it is 1 into 7 square plus 4 into 7 raised to power 1 plus 6 into 7 raised to power 0. Simplify it. 49 plus 28 plus 6. Similarly, here we'll get 3 into 5 square plus 1 into 5 raised to power 1 plus 3 into 5 raised to power 0. This comes out to be 25 plus into 3 is 75 plus 5 plus 3. This comes out to be 83, and this is also 83. Take the sum. So this comes out to be 166, and that is the expected answer. So option 2 is the correct answer. अगर D तक है, अगर 2 भी correct answer नहीं है, similarly you'll substitute here and you'll find out. I'm not going to complete this because already we have discussed the similar one. So is this clear? Method 1 and method 2? Definitely, Hemant, option B is the correct answer for this question. 146 आप base 10 substitute कर लोगे. 313 with the base 10 minus 2 is 8. Similarly, option 4 के लिए 146 with the base 16. 313 with the base 16 minus 2 is 14. So this way you have to calculate. Alright, let's move on to the next question. This is based on the floating point numbers. So we had discussed the floating point numbers. We had discussed the single precision format, a double precision format, that is for 32-bit and 64-bit. But here in this question, they are using 32-bit representation, and whatever result you are getting, you have to return that in the hexadecimal form. It's 32-bit format. Anyone remembers how many bits are used by the biased exponent? Sign के लिए हमारे पास एक ही bit use होती है, that is fixed in all the formats. So there are three fields in the format. One is the sign bit, biased exponent, and mantissa. You need to consider 32-bit format. For 16-bit, 5 bits are used for biased exponent. For 32-bit, 8 bits are used for biased exponent. And for 64-bit, 11 bits are used for biased exponent. One is for the sign bit. Total bits में से जब आप subtract करोगे, you will get the bits for the mantissa. So here we have three fields: sign, biased exponent, and mantissa. Sign, biased exponent, and mantissa. According to 32-bit format, sign bit is always of fixed size, 1 bit. Biased exponent is of 8 bits. 32 minus 9 is 23, so remaining 23 bits are used to represent the mantissa. जब भी हम mantissa को represent करते हैं, mantissa should always be represented in the normalized format. Mantissa should always be represented in the normalized format. Can somebody tell me that what is this normalized format? मैम प्लीज 32-bit कैसे निकले हैं बता दे. ओके, नॉर्मलाइज्ड फॉर्मेट आपको क्वेश्चन में दिया गया है कि जो आप फॉर्मेट यूज कर रहे हो फ्लोटिंग पॉइंट रिप्रेजेंटेशन के लिए, दिस इज IEEE 32-bit रिप्रेजेंटेशन. तो जब हम IEEE 754 की बात करते हैं तो हम लोगों ने सेशंस में देखा है, वी हैव कवर्ड दैट देयर आर टू फॉर्मेट्स व्हिच आर बेसिकली यूज्ड. सिंगल प्रिसीजन मींस अगर यहाँ पे आपको सिंगल प्रिसीजन दिया होता तब भी हम 32-bit फॉर्मेट यूज करते. सिंगल प्रिसीजन, this format is predefined. Single precision, for this we have 32-bit representation. Total number of bits जो single precision में use होती हैं, that is 32-bit. And for double precision, this is 64-bit. अब total number of bits हमें पता है. I'm explaining the format. Total number of bits हमें पता है. 3 fields होती हैं. साइन, क्योंकि जब भी आप किसी भी नंबर को रिप्रेजेंट करते हो, पहली चीज पॉजिटिव और नेगेटिव हो सकते हैं. सो वी नीड टू रिप्रेजेंट द साइन. साइन या तो पॉजिटिव होगा या नेगेटिव होगा. इफ द नंबर इज पॉजिटिव, अगर नंबर पॉजिटिव है वी रिप्रेजेंट इट विद 0. इफ द नंबर इज नेगेटिव वी रिप्रेजेंट इट विद 1. दैट मीन्स only 1 bit is sufficient to represent the sign field. So here also we have 3 fields: sign, biased exponent, and mantissa. Sign, sign, biased exponent, and mantissa. Basically, we use floating point representation to represent very small or very large numbers. So in that case, definitely we will be getting something in the power that is known as the exponent. And here we have the mantissa. अब फर्स्ट केस में हमने ये बोला कि हमारे पास टोटल 32 बिट्स हैं. आउट ऑफ दीज 32 बिट्स 1 बिट इज यूज्ड बाय, एक बिट यूज की साइन ने. Biased exponent is fixed to 8 bits. 8 bits. This is fixed to 11 bits. And this is 1 bit. अब टोटल आपके पास 32 बिट्स हैं. टोटल 32 बिट्स हैं, उनमें से एक बिट का साइन बिट आ रहा है. सेकेंड फील्ड का साइज 8 बिट्स है, तो mantissa का साइज मिल जाएगा. mantissa will be of size 32 minus 9, that comes out to be 23 bits. So that's why I wrote here 23 bits. Similarly here, out of 64 bits, just subtract 12, so it comes out to be 52 bits. So 52 bits are used by the mantissa. So this is how I calculated this. Okay. अब यहाँ पे दो fields आ रही है, biased exponent and Mantissa. Let's understand that how to calculate the Mantissa or the biased exponent. So Mantissa is always represented in the normalized format. किसी भी नंबर को हम normalized format में तब बोलते हैं when you have adjusted the decimal को इस तरीके से adjust किया है कि decimal से पहले आपके पास एक ही digit आ रहा है, that is 1. This is fixed. And after decimal कितनी भी bits हो सकती हैं, it can be any combination of zeros or 1. B is representing, small b means bit, so bit आपके पास 0 हो सकता है या फिर 1 हो सकता है. So the benefit is when in the normalized format, when the Mantissa is in the normalized format, और हमें ये मालूम है कि जो decimal से पहले एक ही digit आएगा and that must be 1, that means we need not to store this. क्यों store नहीं करवा रहे हैं? Because this will save one bit. So we will be just storing the bits which are coming after the decimal in the Mantissa part. Okay, ये होता है normalized format. Now, if we talk about the biased exponent, this is important one. Biased exponent. Biased exponent is nothing but दो terms आ रही हैं. This is the sum of bias plus actual exponent. Bias plus actual exponent. Actual exponent, obvious सी बात है कि अगर मान लीजिए आपके पास कोई नंबर आ रहा है something like Mantissa is there and into 2 raised to power minus or whatever it is e. So this is the actual exponent, means जो भी actual power आ रही है that is known as the actual exponent. ये question to question vary करेगा. Now main focus is on bias. Bias calculate करने के लिए हमारे पास जो highest digit होता है in the 2's complement representation, we are using that formula. So bias is nothing but it is 2 raised to power n minus 1 minus 1. Minus 1 क्यों करते हैं? क्योंकि positive side में 0 is also included. So this is how we calculate the bias. N is representing the number of bits जो आप bias exponent के लिए use कर रहे हो. If I'm considering the example for 32 bit, 32 bit के लिए मुझे bias calculate करना है, तो 32 bit में biased exponent field sizes, biased exponent is of size 8 bits. So I'll be getting here 2 raised to power 8 minus 1. अब यहाँ पे देखिए biased exponent की कितनी bits आ रही हैं? 8 bits. So n की value 8 हो गई minus 1. 2 raised to power 7 is 128. Minus 1 is 127. That means bias for 32-bit format is 127. Similarly, if I'll be calculating it for 64-bit, 64-bit के लिए अगर हम bias calculate करते हैं, then it will be 2 raised to power, number of biased exponent bits are 11, 2 raised to power 11 minus 1 minus 1. So this comes out to be 2 raised to power 10 minus 1, which is equal to 1024 minus 1 is 1023. This is the bias for 64-bit. So you should keep this in mind because usually directly आपको bias given नहीं होता है. So this is the formula to calculate the bias. Bias किसके basis पे calculate करोगे? On the basis of the number of biased exponent bits. This much is clear. So Mantissa should be in the normalized format. Normalized format means decimal से पहले आपके पास एक ही digit होना चाहिए and that must be 1. Biased exponent is nothing but that is bias plus actual exponent. अगर actual exponent और bias पता है तो आप biased exponent calculate कर लोगे. Sometimes you know the value of biased exponent and bias, so you can calculate the actual exponent by subtracting them. Okay. If this is clear, then let's solve our question. So here we are given that the number is minus 40.1. सबसे पहले sign bit क्या आएगी? Sign is minus, so what should be the sign bit? Number is negative number, so sign bit will be, come on. For positive number, we are using 0 and for negative number, we are using 1. So sign bit is 1. Next is 40.1. That means we need to represent 40 and 0.1 in the binary format. This is in the decimal format. This is in the decimal. Can you return its binary? This is in the decimal. We want to represent this in the binary. Just represent this in the binary. So it is 32 plus 8, 4, 2, 1. So I have got 1, 0, 1, 0, 0, 0. Next, 0.1 को भी binary में convert कर दीजिए. So in order to convert 0.1 in the binary, so I'll be writing this as 0.1 into 2 क्योंकि integer part होता है तो we need to multiply it with the base. 0.2 into 2, that is 0.4. Whatever is the integer part, that will be included in the result. 0, 0, 0.4 into 2, that is 0.8. Again you are getting 0. 0.8 into 2 is 1.6. Now we are getting 1 here. Oops. 1 here. Then is zero point 0.6 into 2. That is returning 1.2. Again, 1 is coming here. फिर 0.2 आ गया. उसके बाद फिर से यहाँ से start हो जाएगा. So it will be returning 0011. 0011. 0.4. So again there is a loop. So that means we are getting 40.1. 40 का binary है 101,000 decimal. Then we are getting 0,000,1 1 1. Then again we'll be getting 2 zeros. Then we are getting 1 1 and so on. Now here just we need to represent this number in the normalized format. Is this in the normalized format? This is not in the normalized format because in the normalized format there should be only one digit before the decimal. You can see here in the normalized format decimal से पहले आपके पास एक ही digit होना चाहिए and that must be 1. So let's convert this. कैसे convert करेंगे? We need to move this decimal by how many places? 1, 2, 3, 4 and 5. So this means that I can write this as 1.010000, 3 zeros, then again 3 zeros are coming up. 1100110011 and so on. So here into 2 raised to power आपने कितनी bits move करवाएंगे? 5 bits. So this comes out to be raised to power 5. This means that the actual exponent is 5. Actual exponent is 5. Bias is 127. Now only we have calculated. So biased exponent comes out to be bias plus actual exponent. That is 127 plus 5, which is equal to 132. Represent this 132 in the binary. So this is in the decimal 132 in decimal. Represent this in the binary. So this is 128 plus 4. So 128, 64, 32, 16, 8, 4, 2 and 1. So you are getting 8 bits of biased exponent. So that is 1,000,000, 1,000,000, then is 0100. Biased exponent clear. Mentisa, whatever is after the decimal, we just need to store it. So this comes out to be 0100, 0100, take 000, 00. Just count the number of zeros because sometimes this will give you incorrect answer and so on. तो आपके पास 32 bits आ गई, ये 1100 repeat होता जाएगा. So we have got the bits. So just store it. आपके पास 32 bits आ गई. अब आपको 4 की grouping form करनी है. So you just need to represent these bits. So it is 1 1 0 0. So these are the 4 bits. Okay, let me write here 4 bits. Then is 0 0 1 0 0. Then we are getting 4 zeros. So this way we are getting the numbers. So you can see here we are getting the number as 1 1 0 0 0 0 1 0 0 0 1 0, then is 0 0 0 0, and so on. So 1100 is nothing but 12, that is the hexadecimal for C. This is 2, then this is again coming out to be 2, then we are getting 0, and then we were getting 0 0 1 1 0, that is 6, and so on. So what is the correct answer? So here after that it is going to just repeat 0 0 1 0 0 0 1 0 1 1. तो ये repetition में चल रहे. So here you will getting the same number. So again you will be getting 0 0 1 0 0 0 1 0. So again this is 6. So C220666. Just check for the answer. C2206 and 6. So 4 is the correct answer. Correct? The only thing that you need to understand is here we have to represent this 32 bits in the form of this three fields: sign bit, biased exponent and mantissa. Mantissa कैसे calculate करते हैं, biased exponent कैसे calculate करते हैं, we have talked about that. You just need to convert the actual exponent to the biased exponent by adding it with the bias. Range is given here. We have calculated here. This is just the summary of floating point representation. If you are comfortable with this, then easily you can handle any question. Is this clear? So दो चीजों पे आपको ध्यान देने हैं, एक biased exponent और दूसरा mantissa. कोई doubt, कोई confusion? If no, then let's move on to the next question. The hexadecimal equivalent of the binary integer, you are given with the binary integer and you have to represent this in the hexadecimal. I guess this is the simplest question. क्या करना है? अगर hexadecimal है, hexadecimal means base is 16. 16 means 2 raised to power 4. 2 raised to power 4 means each digit will be represented with 4 bits. तो यानी कि जो आपको बाइनरी नंबर दिया हुआ है उसको आपको ग्रुप्स में डिवाइड करना है by considering 4 bits in one group. So it is 1101 01101. What will be the answer? 1. Okay. So decimal यहाँ पे है नहीं. So we need to form the grouping from the end. 1 2. How it comes out to be 1? So if here enough bits are not there, so it will be 0 0 0. क्योंकि मैंने आपको क्या बताया हुआ है, हमेशा जब भी हम grouping करते हैं, we always started from the decimal side. So in this case, if it is not there, so definitely will be going from here. Very good, Mariam. What is happening? Wait a minute. So this is 0 0 0 1. So this is 1 1 0 1 0 10. 10 is represented by A. 1 1 0 1. This is 12 plus 1 13. 13 is represented by D. So 1 AD, that is 4 is the correct answer. 1 AD. Yes, definitely 1 AD is the right answer. Comfortable? Next one. The micro operation which divides a signed binary number by 2. कौन सा नंबर है कौन सा इनमें से अप्रोच है, कौन सा शिफ्ट है जो आपको साइंड बाइनरी नंबर देगा? साइंड बाइनरी नंबर। स्टार्टिंग से निकालने लगे, स्टार्टिंग से ऐसी गलती नहीं करनी है, हमेशा आपको ग्रुपिंग करने के लिए डायरेक्शन बताइए, ऑलवेज फॉलो दैट डायरेक्शन एंड विद दैट अप्रोच यू विल ऑलवेज गेट द करेक्ट आंसर। चाहे आपको सिर्फ इंटीजर नंबर दिए या इंटीजर के साथ फ्रैक्शन दिए, दैट्स ओके। Anyways, what should be the answer for this question? The micro operation which divides a signed binary number, so the number is the signed binary number, by 2. अगर आपको कॉन्सेप्ट पता है आप डायरेक्टली आंसर रिटर्न कर सकते हो, अदरवाइज कंसिडर सम साइंड बाइनरी नंबर एंड देन ट्राई अप्लाइंग द सर्कुलर शिफ्ट, लॉजिकल शिफ्ट, अरिथमेटिक शिफ्ट राइट, अरिथमेटिक शिफ्ट लेफ्ट, ये सारे शिफ्ट्स हमने किए हुए हैं. We have covered all these shifts in detail, so easily you can apply it if you are considering some number. Take some number, let's say it's 1010. Okay, if I'll be shifting the bits, हमें मालूम है कि अगर हम bits को left shift करते हैं then it is going to return. If I'm going to shift this bits towards the left, 0 1 0, and here new 0 is introduced, so this is nothing but 6 16 plus 4, that is 20. This is the binary of 10, this is the binary of 20. This means that left shift is multiplying by 2. Left shift multiplies by 1. Left shift means multiply by 1. Left shift means multiply by 2. Similarly, if I'm using the right shift, so it is 1. Okay, let's take this number. So if I'm shifting these bits towards the left, this is the least significant bit. So this bit will be discarded. So here we'll be getting 1, here we'll be getting 0, and here we are getting 1. So 20 is represented, 1 right shift means it is dividing the number by 2. Again, I'm going to shift it. So here I'll be getting 1. Here I'll be getting 0. Here I'll be getting 1. A new 0 is introduced. This is what we do in the logical shift. So now this is the binary of 5. So number था आपके पास 20, then it is divided by 2. We are getting 10. Then again divided by 2. So we are getting 5. This means that one right shift means divide by 2. One right shift means divide by 2. That means for dividing the number by 2, we need to follow the right shift. अब अरिथमेटिक राइट शिफ्ट और लॉजिकल राइट शिफ्ट में डिफरेंस कहाँ पे आएगा? लॉजिकल राइट शिफ्ट में जब भी आप शिफ्ट करते हो बिट को, तो जो लेफ्ट मोस्ट बिट होती है दैट इज इन लॉजिकल राइट शिफ्ट, सारी बिट्स शिफ्ट होगी तो जो लेफ्ट मोस्ट पोजीशन होगी दैट विल बी एम्प्टी. सो इन लॉजिकल राइट शिफ्ट all the bits are shifting including the sign bit. All bits are shifting including the sign bit. अब अगर सारी bits को change करें, if we are shifting all the bits towards the right और आपने sign bit भी move करवा दिया, तो जो नई bit introduce हो रही है, adding most significant bit is added as 0. तो इससे क्या होगा? Sign will be changed. Sign will change. क्योंकि लॉजिकल राइट शिफ्ट में या लॉजिकल लेफ्ट शिफ्ट में सारी बिट्स मूव होती है और राइट शिफ्ट कर रहे हो तो साइन बिट भी चेंज होगी. साइन बिट जब मूव हुई, अगर मान लीजिए आपके पास नेगेटिव नंबर है, साइन बिट वाज 1, इफ यू हैव मूव दिस and new bit added is the 0, that means number positive हो गया. -20 को जब आप डिवाइड बाय 2 करोगे, आंसर शुड बी -10. साइन चेंज नहीं होना चाहिए, बट लॉजिकल राइट शिफ्ट क्या करेगा, इट विल चेंज द साइन एज वेल. लेफ्ट शिफ्ट तो डेफिनेटली आंसर नहीं है बिकॉज दिस इज यूज टू मल्टीप्लाई, but here we are focusing on the divide. Right shift definitely divide करता है. Circular shift won't be giving you the answer. थोड़ा बहुत आपको डाउट ऑप्शन 2 और 3 में हो सकता था, लॉजिकल शिफ्ट और अरिथमेटिक राइट शिफ्ट. तो अरिथमेटिक राइट शिफ्ट में क्या होता है, वी विल बी शिफ्टिंग ऑल द बिट्स टुवर्ड्स द राइट एक्सेप्ट साइन बिट. साइन बिट शिफ्ट नहीं होती है. सो इससे क्या होगा, जो भी नंबर का साइन होगा दैट विल बी प्रिजर्व्ड. Here we are considering the sign of a number, so definitely the correct answer for this question is it's option 3, that is arithmetic shift right. Make sense? Is this clear? ये shifts हमने किए थे in COA in unit 2. I hope you all remember the concept of shifts. Okay. One more question. Identify the code sequence. You are given with some code sequence and you have to tell that whether this is the BCD code, XS3 gray code or the XS3 gray code. Can you identify that? Take 30 seconds and try to identify whether this is the BCD code, XS3 gray code or XS3 gray code. One zero one zero 1011 1001 1000. अगर हम BCD की बात करते हैं, in BCD we can represent only the digits from 0 to 9. Binary coded decimal digits कौन से आएंगे, 0 to 9. So this is, first one is invalid BCD. 1010 is not used in BCD, so that means 1 cannot be the answer. मरियम, सबसे पहले हम ऑप्शन 1 को ही डिस्कार्ड करेंगे. BCD में आप सिर्फ 10 कॉम्बिनेशंस यूज करते हो, स्टार्टिंग फ्रॉम 000 टू 1001. 1010 से लेकर all 4 ones तक आपके पास जो 6 combinations होते हैं, those are the invalid BCD codes, right? So option 1 BCD cannot be the answer. Let's check for XS3. Is this the XS3 code? If I'm finding this, यहाँ पे दिया हुआ है आपको 1010, that means 10. अगर ये XS3 है तो किसका XS3 होगा, 7 का. Then this is 11, so 11 minus 3 8. ठीक है, सीरीज में आ रहा है 1001, that is 9 minus 3. Is it giving you any sequence? This is 8 minus 3, that is 5. Is it giving you the sequence 7 8 then 6? This is not possible, so this is not XS3. Gray code is the unidistant code. Let's see if it's a unidistant code. Only one bit is changing here. Only one bit is changing here, so this is okay. Here also only one bit is changing. This is unidistant. Here again only one bit is changing, so it is unidistant code. So whatever codes are given to you, this is a unidistant code. Unidistant means दो consecutive numbers के बीच में सिर्फ एक ही digit change हो रहा है, only one bit is getting altered. Such a code is known as unidistant code. So this is undoubtedly not XS3. This is the gray code, not XS3 gray code. So this is all about this session. I hope that this is clear. So sometimes they'll give you some codes. You have to identify the code. So you should know that what is XS3, what is gray code, what is BCD code, binary, and so on. Anyone having any doubt? We'll be discussing a few more questions from digital. कल वाले session में I'm thinking to take the questions from counters as well. Counters or जो sequential circuits and combinational circuits. Okay, so revise the concept of sequential circuits and the combinational circuits. In the next session, we will be discussing the questions from those along with K-map. क्योंकि अभी तक हम हमारे पास के मैप का कोई क्वेश्चन नहीं आया वी हैवंट डिस्कस्ड एनी क्वेश्चन फ्रॉम काउंटर्स or combinational circuits. So in the next session, I'll be focusing on that. So this is all about this session. If you guys have any doubt, any queries, you can ask. And कुछ लोग सोच रहे होंगे मैम आपने कहाँ पे ये सब डिस्कस किया आई हैव डिस्कस्ड ऑल दीज कॉन्सेप्ट्स इन डिटेल इन द सुपर कोचिंग बैच सो सुपर कोचिंग बैच का जो link है that is given in the description box. If you want to get to know more about super coaching, just go through that link. And you can also join our official Telegram group, and the link is again given in the description box. So you will get a lot of information related to this super coaching. And अगर फिर भी कोई doubt है तो feel free to post your queries in the Telegram. Okay. So this is all about this session. And in the super coaching, we are covering all the units in the live sessions. तो paper 1 और paper 2 दोनों के सारे units live session में जा रहे हैं. Paper 2, paper 1 के लिए we are having the session in the noon 12:30 p.m. Monday to Saturday. This is the schedule that we are following because we are planning to finish our whole syllabus by April so that मई में और जून के जितने भी दिन होंगे आप सिर्फ और सिर्फ अपनी रिवीजन और टेस्ट सीरीज पे ध्यान दे पाओ so that you can crack the exam in the first attempt itself. Because practice के बिना आप कितना ही पढ़ लो आप टेस्ट सीरीज नहीं दे रहे हो प्रैक्टिस नहीं कर रहे हो तो it's really very difficult to crack the exam in the first attempt. So in the morning, we are having the 2-hour session starting from 7:30 a.m. to 9:30 a.m. And in the evening, we are having the session from 8 p.m. to 10 p.m. And there is no off on weekends, no off on weekends. अगर आपको लगता है किसी पर्टिकुलर टॉपिक में बहुत ज्यादा प्रॉब्लम आ रही है जस्ट लेट मी नो आई विल एक्सप्लेन दैट टॉपिक but obviously I'll be just covering the important topics or the questions on the YouTube. So there is no off on weekends, but definitely for morning, Thursday is off. For evenings, it's Monday and Tuesday off. So this is the schedule that we are following. Do you guys have any doubt? अगर कोई doubt नहीं है तो obviously we'll end our discussion here. I'll see you in the next session. And again, we will be solving the questions in that session too. All right, since there is no doubt, so I'll see you in next session. Till then, take care. Bye bye. Thank you for joining the live session. Bye bye.